When something's going in a vertical circle, the force that's pulling it in a circle, so in this case the tension, whatever that force is, it's always got to be greatest at the bottom. At the bottom of a circle, that's where gravity's going the absolute wrong way, and it's accelerating upwards, so the tension or whatever the force is has to be bigger than gravity to cancel out the gravity, and then big enough to create that mv squared over r. It has to create that unbalance. It is accelerating, there has to be an unbalanced force. At the top, it's not as hard on the tension because gravity's sort of in the right direction. Gravity helps the tension bend it in a circle at the top, but at the bottom, gravity's going the wrong way. So tension's got to beat gravity and then some. So if there's ever a question about something breaking or hitting a limit before of a too fast issue, that's almost always a bottom thing. Now I got to be careful how I say that because we will get to a too fast situation later, a biker going over a hill. So for this one, the key was to recognize that it's at the bottom. That's when the string could break, and then it turns into an F net equals ma. The a turns into v squared over r since it's going in a circle, and we've seen this free body diagram a bunch of times. Maybe it was a crane lifting something, and the tension upward was overpowering the gravity to accelerate it upward. Same idea here, the tension's overpowering gravity to cause it to accelerate upward. Just this time the acceleration is centripetal. The way this one's worded, we're asked for speed. We know everything but the speed. So if I just plug things, well, let's do one more line. Ft minus mg equals mv squared over r. It can handle 5 newtons of tension, so we're going to sub that in as our force. This will be the max speed. The m of 0.3 times 9.8 equals 0.3. I don't know, squared, and the r that I made up was 1.5. So 5 take away 3 times, 0.3 times 9.8 is roughly 3, so 5 take away 3 is 2. 2 times 1.5 is roughly 3 again. Then we've got to square root that whole thing. We got to divide by the 0.3, we get roughly 10, so we're at the square root of 10.3-ish. When I square root that, I'm getting around 3.2 meters per second. The key to this one is the structural integrity of our string is at its limit when the object is